Okay, so on this question, they give us a function. They give us a delta x and a zero, and they want use linear approximation to estimate delta y. So first off, they want dy. So let's bring that on down. So we've got y equals sine 3x, and can we want the derivative? So the derivative, oh, and the derivative is, I'll use Leibniz notation, helpful in this situation. It's dy dx, right? Derivative sine is cosine. Keep the inside the same at first times chain rule. Yeah, we do it over the top. Chain rule says do the derivative of the inside. There we go. Okay, and then you want dy, so multiply both sides by dx. These will cancel out. And so dy is cosine 3x times 3 dx. So let's plug this stuff in. dy is cosine, what is x? Says dx is 0. 3 times 0 times 3. And what is dx? This right here, dx and delta x are the same. So there's no difference between those two. They're the same thing. That just means D stands for difference. This triangle here also means difference. It's a Greek D called delta, and it just means the difference in x value, 0.1. So that's going to be 0.1. So there we go. So dy will equal, let's go to Desmos and hit the buttons. So we cosine of 0 times 3 times 0.1. So cosine of 0, 3 times 0.1 becomes 0.3. 0.3. All right. Because this inside was just 0. So that's why I did that. Okay. And sure enough, there's our first answer, 0.3. That's dy. Now it's saying find the actual change in y, delta y. Now that is a little delta y and dy are not the same. How do we find delta y? That means y2 minus y1. That means a change in y values. So let me show you on the graph. So here's the graph. And the blue function on the top is the slope of the tangent line. Which happens to be y equals 3x. It's the tangent line. I'll explain later how I figured that out. And the bottom function, the red one, is the original, which is, what was it? Y equals sine of something or other. Sine 3x. Sine 3x, that's the original. So basically, the original function is the red, and the blue is the tangent line. What is a tangent line? It's a line that barely nicks a curve in only one point. And so they meet here at 0. Right at 0, they're right on top of each other. As they spread out from there, the red one's a little lower, blue one's a little higher. The tangent line, they meet right here, and then they go out. How do we know? It says at x equals 0. Where I'm using I'm using the tangent line. So how do I find the difference in y values? What does that mean? Well, that means as you go from x, we're going from x equals 0, and then delta x is 0.1. So that means the first value is 0, and the second value is 0 plus 0.1, which means 0.1. Because again, delta x means the difference in x values. So if the first one's 0, right, they give us the first one 0, and the jump, the difference, this is the delta x, as you could call it, the jump, the difference, or the jump. So from the first x value to the second x value, you got to add 0.1. So the second value, just since the first one was 0, the second one is just 0.1. So what they're asking us is, what is the difference in y values between those two x values? So for example, when x1 is 0, what's the original function value? It's y equals sine 3x. When you plug in 0, you're going to get y1. I mean, y1, we're plugging in x1. y1 will be sine of 0. So y1 is just 0. And then over here, I'm going to use same function, sine 3x, but now I'm going to plug in the second x value. So what I get is going to be y2 sine of 3 times 0.1. And Desmos will help me out with what that is. 3 times 0.1, sine of 3 times 0.1, I don't know. Sine of 3 times 0.1. Here we go, 0.2955, 2955. So it's 0.2955 and some other stuff here. 202067, 202067. Okay, so there's y2, there's y1. So, okay. So, then so on the graph, let me show you on the graph. So we're going, so the delta, well, let's finish this up first. The delta y, which is what they were asking us for. The delta y, let's keep these separate here. The delta y is y2 minus y1, right? Means difference in y values. So it's the y2, 0.2955202067 minus 0. The y1 is just 0. Y2 minus y1. So then the delta y is pretty obviously just the 0.2955202067. Okay, now that's not our final answer yet. So they're saying find delta y, we did, and then find the error between the linear between dy and delta y. How different are dy and delta y? That's what they're asking us for. So dy 0.3 right there. Take away delta y, this thing, 0.2955 202067. So it's got to subtract those. That's called the error between them, between dy and delta y. I'm going to just go to Desmos, and I just take as 0.3 minus that last answer. And I get 0.00044797. And 0.004797 should be 933. And oh, they just wanted to give your answer as a positive number to 7 decimal places. Find the actual change and then find the error between the linear approximation dy and the actual change delta y between the linear approximation dy and the actual change in delta y. Give your answer. So there it is. That small answer. I don't know why they have a different answer there. I'm gonna have to check on their thing. But there it is. What do we do graphically? We just we found the delta y because we went from x is 0, which is right here, to x is 0.1, which is right there. So that is the, you want to see graphically what just happened. That is the delta x or dx or delta x, same thing, which was 0.1, right? The x1 value is 0, the x2 value is 0.1. Okay, between those two x values, what happens? Well, here's the y value, and here's the that. So basically, the dy, or the delta y, I should say, the delta y, this is the y height, this is y1, this is y2's height, and then the dy goes all the way up to the blue. That's a little bit bigger. The dy is a little larger. So the dy, the d stuff is always for the tangent line because it's derivative, right? Tangent line is the derivative. Slope is the derivative. Slope of the tangent line is the derivative. So whenever they say dy, whenever they ask us anything about dy, they're saying, what is the difference as you go from your first x value to your second x value? What's the difference in heights? Oh, wait a minute. No, I'm sorry. I am blowing it. Oh, no, no, that's right. No, that's right. Yeah, between the first, oops, don't do that. Between the height of the first point and the height of the second, that's y1, y2 on the red actual curve versus the blue is just above it. That's the difference in y values up to the tangent line. It's a little higher. dy is just a little higher. Yeah, dy is 0.3. The other one's 0.29555. There we go. That's what we just found. So how did we do it? So the delta y is the difference in the two actual y values. When they go delta y, with the delta, you're doing the actual y values from the original function. That always means delta y is always the original. And then dy over here is always from the tangent lines. That's what you got to keep straight. Whenever they're asking you about dy and delta y and stuff, there is no difference between delta x and dx. They're the same, but the y's are different, right? Why are the x the same? Well, look in the graph. We're going, the same x separation, but what's different is how high up to the red or how high up to the blue. That's different. The delta y is always the original function. The dy is always the tangent line. It's up to the blue tangent line. The dy is like dy dx, slope notation, slope of tangent line, slope of the original slope of the tangent line is the derivative, right? So that's how we do that. There we go.